much. Our next presenters are from TANBREEZ Mining Greenland. Please welcome Bolette Maqe Nielsen, who has been the chairman of TANBREEZ since February 2017 and has been working for TANBREEZ for 8 years. She was born and raised in Greenland and lives in Nuuk. She has nearly 18 years of work experience in the mining business in Greenland and has more than 30 years experience in accounting and administration. She's also the board member of the Nuuk Employers Association. Also, Greg Barnes, who has nearly 50 years of experience in the mining industry and more than 25 years in Greenland. He has worked on 4 continents as a geologist, targeting commodities including rare earths and other specialty metals, precious metals, iron ore, and hydrocarbons. Greg is the 100% owner of TANBREEZ, which owns the TANBREEZ project, which is part of one of the largest undeveloped rare earth projects in the world. Welcome.
Thank you for the opportunity to speak. Greg and I decided to do the presentation both, so I take the easy bit and Greg do the rest. So what do? I push this? Where do I push?
There's the green to go ahead.
Yeah, okay. Yeah. As many have heard before, TANBREEZ stands for the elements of tantalum, niobium, rare earth elements, and zirconium. However, TANBREEZ also have the other elements like tungsten, and hafnium. All those elements occur in the mineral of eudialyte. The other minerals are feldspar and aphetonite, which are saleable also. At last year's PDAC, the mining industry and others were given an opportunity to express the need to rapidly streamline the producers in Greenland. Both the minister then and the current minister, together with the one constant, the deputy minister, and the staff need to be congratulated on the results. We are not there yet, but things have improved. Although we don't have an exploitation license yet, we believe we are much closer. And here we clearly see the minerals. The pink one is the eudialyte, and the black one is the aphetonite, and the white is feldspar. One of the most helpful groups in Greenland for TANBREEZ has been the Guyasak community, led by Mayor Kirsta Isaksen and with people of the caliber Rasmus Rasmussen, Ole Christiansen, and Vice Mayor Simon Simonsen. This group has been incredibly helpful and should be singled out as a group whose assistance has been amazing. An example of South Greenland's assistance was during the USA ambassador to Denmark's visit to Greenland in August last year, whereby they organized a fully catered boat to transport them to the TANBREEZ site. When they got to the site, the hospitality did not end, as there was a helicopter waiting to take the group to the best sites. In fact, I believe the hospitality was still flowing well into the night. To give an idea of the size, the area of the ore body is 5 kilometers long, 3 kilometers wide, and 400 meters above sea level. Some idea of the site is to take a look on a camp, if you can find it. I don't know where to point it, I think, yeah, here's the camp. So where does TANBREEZ stand? I'll leave it all to Greg.
Thank you. That's assuming I can work this machine, of course. Our current resources stand at 4.7 billion tonnes at a grade of about 1.9% zirconium and about 0.6% rare earths and 0.2 niobium and 0.03 tantalum, tungsten and hafnium. But because it rapidly and very easily separates The black ones are very magnetic, the red ones are partially magnetic, and the white's non-magnetic. So you effectively upgrade very quickly. To give you effectively a grade of 9 to 10% zirconium, 2.5 to 2.7% zirconium, rare earths, 1% niobium, and 0.15 the rest. And because we can sell, believe we can sell the feldspar and elphinstondite, that process probably is free of charge, so that's probably effectively a head grade. Some basic figures. At this stage, our expenditure is roughly 50 million Australian dollars, with followed-up expenditure probably 15 million by people previously. The total number of drill holes is 414, and we've got somewhere around 350,000 separate assays on the samples. We've taken 709 tonnes of bulk samples, which have gone through the various processes. So we know a lot about the deposit. As you can see there, there's 1,600 separate batch tests of over 1 kilogram, and some of those get up to 70-tonne bulk samples through the plant, through various plants. The same on the chemistry side. So we know we can get all the various elements out, and exactly which way we can do it. In 2019, as we were working forward on the political side, and I do thank people for what's happened there, we went back to doing some basic research. Now, I'm lucky enough in that the other gentleman that does all the work with me, Hans Christian, he used to be Deputy Minister. He's gone back to playing with a microscope, and he spent the whole year on a microscope. And we're actually finding that the geology's changed around. We're actually found that instead of being a magma chamber, it's actually all metasedimentary rocks. And we've been able to probably map what the original rock types were. And part of that metasomatic process is we're getting this pulses of eudolite coming through the rocks, metasoming, altering everything, but giving potential for larger deposits of just pure eudolite. That's eudolite there, the red mineral, and that's the example of solid rock of just virtually eudolite. Eudolite comes from the Greek word meaning easily dissolved. It dissolves in 1 molar acid, and it gives you virtually zirconium, tantalum, niobium in solution, better than a competition. Zircon, the mineral for zirconium, is probably the world's most stable mineral. You need hydrofluoric acid or etc. to dissolve it. Here we have a zirconium mineral, dissolves in weak acid. And what we're finding is that if you get the right chemical conditions, eudolite gets pushed through the deposit, gets dissolved from one place and deposited somewhere else. And it's that somewhere else that we're starting to get to understand better. Now, high-grade deposits, although we have a process for mining a low-grade, high-grade deposits gives us an opportunity for a smaller high-grade mine, which we're talking to the business school about, or so the mining school, about the idea of some sort of school for mining. We've also found there's 3 different, if you like, pulses of eudolite. There's one older one that's we've got about 46% heavy rare earths. That's of the rare earth content, 46% heavy rare earths. The most common one is around nordurite, which goes about 35%, and then the catorquitite, which is our main ore body, goes about 30% heavy rare earths. Heavy rare earths are the more valuable member of the rare earth, things like diosporium and terbium. To give you some idea, the ore body is on blue. You'll see the solid. The extension to that is to the northeast, is dotted, and this area we're finding in this new eudolite deposit is being put as red dotted. Large areas, large tonnages potentially, which is an example there. And there's a picture of the cliff. The cliff is about 400 metres high of ore, and we are confident we're going to find a lot more of this particular high-grade material. Let me pick up on something that Bolette said. I really feel this year, and over the last 5 or 6 years, the help of the local community has been rather spectacular at finding labour to help us in the field, and also thank the ministers and the ministry this year have been clearly needed to get move on the whole thing, and I thank the minister and the previous minister as well for that. And we've got a considerable amount of work we're going to do this in the season. There's a picture of the ore body again. That virtually is total ore. It's about 400 metres thick. It goes back from there about 3 k's, and 97% is ore. That's the main ore body. We haven't talked about the other 3 or 4 ore bodies. Something we think at the moment we have 29 million tonnes of rare earths. We think we could get that fairly quickly up to 69 million tonnes of contained rare earths, which would be double what China's got. And I thank you for your time.